The pursuit of artificial intelligence is a profound endeavor, aiming to replicate and perhaps even surpass human intelligence. Yet a fundamental philosophical challenge stands in its path: nominalism. Nominalism, in its essence, posits that our categories and concepts are merely convenient labels, lacking any inherent connection to a deeper reality. This presents a significant hurdle for AI, as it grapples with representing knowledge, understanding meaning, and navigating a world rich in relationships and emergent properties. Current AI systems, while impressive in their computational prowess, remain fundamentally nominalistic in their approach. They excel at identifying patterns and making predictions within predefined categories, but struggle to grasp the underlying relationships and emergent properties that characterize human cognition. This essay delves into the limitations of current AI training methods in addressing the nominalism problem, highlighting the urgent need for a paradigm shift towards relational emergent approaches. The implications of AI's nominalistic constraints are far-reaching, from limitations in generalization and ethical reasoning to the potential for exacerbating societal fragmentation. The consequences of neglecting this philosophical challenge are significant. As AI becomes increasingly integrated into our lives, it is crucial to address these limitations and chart a course towards a more robust and responsible AI future. At the heart of modern AI lies data. Massive datasets, meticulously labeled and categorized, fuel the learning algorithms that power everything from image recognition to natural language processing. Yet this reliance on data-driven approaches inadvertently traps AI within a nominalistic framework. Data, by its very nature, is a representation of reality, a simplified and categorized version of the world filtered through the lens of human perception and labeling practices. When AI systems are trained on this data, they inherit its inherent nominalism. They learn to associate patterns with predefined categories, becoming adept at recognizing a cat in an image because it conforms to the features and labels associated with the category cat. However, this understanding remains superficial, lacking the richness and depth of human understanding, which encompasses a cat's behaviors, its relationship to other animals, and even its cultural significance. This reliance on predefined categories limits AI's ability to truly understand the world in its full complexity. It leads to a rigid and inflexible form of intelligence, prone to errors when faced with novel situations or concepts that defy easy categorization. To overcome this limitation, AI needs to move beyond the surface level of labels and delve into the underlying relationships and emergent properties that define our world. One of the key limitations stemming from nominalism in AI is the problem of static categorization. AI systems are trained on datasets that represent a snapshot of the world at a particular point in time. Categories once defined remain fixed, even as the world itself is in constant flux. This creates a fundamental mismatch between the dynamic nature of reality and the static nature of AI's understanding. Consider the concept of a smartphone. What constituted a smartphone a decade ago differs significantly from our understanding today. Yet, an AI system trained on data from a decade ago would still operate with the same static definition, struggling to accommodate the evolution of this category. This rigidity makes it challenging for AI to adapt to new information, evolving concepts, and the relationally emergent differences of a constantly changing world. This limitation is not merely an academic concern, it has real-world implications. As AI systems are increasingly deployed in dynamic environments, from self-driving cars navigating busy streets to financial algorithms responding to market fluctuations, their ability to adapt and learn on the fly becomes crucial. Overcoming the constraints of static categorization is essential for AI to achieve robust and reliable performance in real-world scenarios. If AI development continues on a nominalistic path without adopting relational emergent approaches like heuristics, the world by 2040 could face severe disruptions. Here's a projection of how things might unfold by then. Hyperpolarization societies could become more fragmented with extreme political, social, and cultural polarization. AI-driven content would further silo people into ideological echo chambers, making consensus on global issues harder. Social unrest, deepening divides, reinforced by nominalistic algorithms, could lead to more frequent social unrest and conflicts. Widening wealth gap. AI will concentrate wealth and power, benefiting those who control these technologies. The disconnect between financial algorithms and human realities will create severe economic disparity and instability. Economic volatility. Nominalistic AI managing economic systems could increase volatility and market disruptions. Automation. By 2040, nominalistic AI could displace significant human labor, especially in middle skill and creative jobs. Narrow AI's inability to grasp relational differences will compound job displacement. AI-controlled societies. Governance might increasingly rely on AI, leading to a loss of human agency. Depleted ecosystems. Nominalistic thinking leads to linear solutions for complex environmental issues. AI may recommend exploiting resources based on economic gains, leading to accelerated depletion and collapse. Climate crisis. Nominalistic AI could prioritize short-term gains over long-term planetary health. Diplomatic failures. Nominalistic AI-driven decisions could exacerbate geopolitical tensions. Miscommunications and mistrust between nations may rise due to AI's failure to grasp cultural differences. Global conflicts. AI-driven warfare could increase, with automated systems driving conflicts based on nominalistic logic. The inability to resolve complex disputes relationally could trigger large-scale wars. Urgency for relational emergent AI, evrostics. Without immediate action, including a shift towards relational emergent AI, the world may face irreversible fragmentation by 2040. Addressing these issues now is critical to prevent these scenarios, and adopting frameworks like evrostics is vital for a sustainable, coherent future.